Alright, so I want to do a review here of what we already did in class, which was talking about modular exponentiation. This was a way that we could compute large powers of numbers using a trick. So here's the basic setup. Suppose you want to know, and let's just work modulo 13. Suppose you want to know what 7 to the 35th is. So 7 to the 35th mod 13, right? We could multiply 7 by itself 35 times and then divide by 13 and find the remainder. But if these numbers are really big, that's going to be very inconvenient. So we're going to use a trick. So here's what we did in class. 35 equals 32 plus 2 plus 1. We write this as a sum of powers of 2, right? And this is 2 to the 5th plus 2 to the 1 plus 2 to the 0. So 7 to the 35 equals 7 to the 32 plus 2 plus 1. And exponents say this is 7 to the 32 times 7 to the 2 times 7 to the 1. Okay, and there's lots of ways we could have written 35 as a sum of numbers, but we write them specifically as a sum of powers of 2 because we can calculate these things fairly painlessly. So again, we're just going to work mod 13. I'm not going to keep writing it. But thinking mod 13, 7 is just congruent to 7, right? So that's 7 to the first. 7 squared is congruent to 49. And 49 mod 13, well, 13 times 3 is 39, so this is going to be 10. And that's also negative 3. And I'm picking negative 3 as a congruence because it's smaller than 10, but you could use either way. 7 to the 4th is the square of 7 squared, so this is 10 squared, which is 100. And 100 mod 13, well, 13 times 5 is 65. 13 times 6, let's put some scratch work down here, is 78. 13 times 7 is 91. That's probably our answer. So this is congruent to 91, which, 91 is a multiple of 13. This is 9 more, so this is congruent to 9. Right? But if I had stuck with 7 squared is congruent to minus 3, I could have said 7 to the 4th is congruent to minus 3 squared. Minus 3 squared is 9, and I'd be done. And this is also minus 2. So 7 to the 8th is congruent to 4, that's minus 2 squared. 7 to the 16th is congruent to 16, which is 5. And 7 to the 32nd is congruent to 25, which is congruent to 3. Lots of busy work. Why did we do this? Because we now know 7 to the 32nd, 7 to the 2nd, and 7 to the 1st. And so 7 to the 35th is congruent to this thing times this thing times this thing. 7 to the 32nd is 3. 7 squared is congruent to minus 3. And 7 to the 1st is 7. This is minus 9 times 63. Sorry, minus 9 times 7, which is minus 63. And we got to do a little work to find what this is, mod 13. But we can just start adding multiples of 13. So this is minus 50, which is minus 37, which is minus 24, which is congruent to minus 11, which is congruent to 2. So 7 to the 35th should be exactly 2 more than a multiple of 13. And if we go back into our binary calculator and we say 7 to the 35th minus 2, we get this big long number. And if we take this number and we divide it by 13, we should get an integer. There you go. So 7 to the 35th is actually 13 times this number plus 2. All right. So that was a little fast, but that's a review of something we already did in class, and we'll play around with this a little bit more on the board in groups.